Hello, and welcome to our program, Astronomy for Everyone. We've been looking forward to this month's topic. It's the Solar Eclipse 2017. Hopefully, many of you had a chance to go out and observe the eclipse. And during this program, we'll be talking to both imagers and visual observers to see what they saw and hear about their experiences. With me here in the studio is Tim Campbell and Liam Finn. Gentlemen, welcome back to the program.
Thank you, Nan.
Now, this is the imaging part of the show, so let's get started. Liam?
Okay, well, we actually went to Casper, Wyoming, which most people who are going to be on the show tonight would have done. And we're going to talk a little bit about our setup that we had in Casper, which was fantastic. We have to admit it was phenomenal. And as well as that, we am going to show some of our images and talk about the process that we go through to set up these images. So some of the images that you can see on the screen right now are images of our setup. You see multiple telescopes there, and you'll see the telescopes are actually wrapped with a foil.
Yes.
Now, there's a reason why we do that. I have a sample of the foil here. So this is a sample of the foil. And basically what it is, it's one of these Mylar rescue blankets.
Okay.
And some of them actually come with, are normally silver, but some of them come with silver and gold. Now, the reason why we chose the gold is because gold reflects infrared radiation.
Which is heat.
Which is heat, a lot better, far greater than silver does. And because we're going to be out in the daytime sun, in Wyoming it was in the 80 degrees mark, somewhere around in mid-80s. So the foil, by wrapping our equipment with the foil, actually reflected some of the heat and stopped our equipment from overheating during the eclipse, because we were leading into, heading towards noon and 1 o'clock, which is actually a really hot time of the day. So wrapping it with the foil really helped our equipment and stopped it from getting so hot that it shut down and we'd end up losing all of our images.
Exactly.
Yeah. Now, Tim and I were both part of a program called the Eclipse Mega Movie. Thank you. And the Eclipse Mega Movie is run through UC Berkeley and in conjunction with Google. So we were out there taking images for that and for ourselves, because astronomy is what we do. So we were out there taking images for that, and anyone who wants to find out about that can just Google Eclipse Mega Movie and they'll find it online.
Great.
So that's why we wrapped our equipment. So we were all set up for our imaging, and to take images through a telescope of the sun, you need to have a solar filter, a proper solar filter. Now, here is one that I created myself, homemade. I bought the special film for it.
The Beta film?
The Beta film. And I made a filter for my own scope. You can buy them also specifically made for your type of telescope. But the idea of them is to go on the front of the telescope. You might see it in some of the images that we had up there. You had a filter on the front. And you can even see behind me here with these binoculars, there's actually a filter on the front of the binoculars.
Exactly.
Which actually blocks the light before it enters the telescope, not after. If you put it on the filter on the eyepiece, it won't work. It needs to block the light before it enters. So we have these. And I think we have another image, and I'll briefly show you. We have a solar projector. Now, this was used during our eclipse, and the idea of this was to show the eclipse, the phases of totality to the general public who are going to be there. So here's an example of the image projected onto the side of a tent, and a board that we had on the side of a tent. And that tent is actually 80 feet away from this projector. And basically how it works is the light comes in from the sun. This is pointing at our tent. The light comes in from the sun, hits the mirror, and by tilting and adjusting the mirror, we can redirect the light through this lens. And at a distance of 80 feet, it creates this projection, which is really nice.
Wow.
So, and one of the nice things about this is it turned into, we just thought it was going to be nice for people to see. It turned out that people started using it as a photo booth. So we had people lining up to stand in front of this piece of cardboard hanging up on the side of a tent, taking selfies, and even having their friends taking images of them standing in front of the different phases as totality was going on. So we ended up creating a photo booth, unintentionally, but that's what ended up happening.
Fascinating.
Yeah,
that's a very interesting piece of equipment. It's the first time I've ever seen anything like that.
Yeah, and
I've seen the sun spotters that you can use. It. You have to kind of crowd around a bit more, but this would give a wide audience a chance to see the various parts of the eclipse.
And that was part of it. Now, then our setup that you saw in the images was actually, as I said, in Casper. It was in South Mike Cedar Park in Casper. And we actually arranged that position, that location, by speaking with the city of Casper themselves. We actually contacted the city of Casper to book that location. And they were phenomenal. I mean, like the days leading up to it, we were talking with them, communicating with them continuously to make sure we were ready. Everything was set for the park. But the day we actually turned up was actually really good. Like we turned up on the day, and the park manager came over and met with us, and he had the sprinklers off in the park to make sure there was going to be no sprinklers going off because we set up our equipment the day before. He had he was talking about lights because there was a public pool nearby that had photosensitive lights, and he even turned around to us and he was telling us about the different lights, and he shut those lights down the day before because he was talking with us because he knew they'd interfere with our setting up our equipment the night before, and like they went out of their way to accommodate us in every possible way. It was amazing. Their workers did. You asked them for anything. They even said they even directed us towards. We weren't expecting it. They directed us towards power in the park that we could tap into as well. So then that was
it sounds like a great place. It sounds like your setup was great. Let's take a look at some of the images that you and Tim were able to capture.
Certainly. So the first images that we're going to show is an image of the sun, showing some of the sunspots, and as part of the sunspots, you see the little black curve at the side and the right hand side of the image. That's actually the moon starting to encroach on the sun as it's passing in front of it, and you can see some of the sunspots just slightly off center there, to the right off center, and also on the left hand side, on the limb on the left hand side. And then over time, over the space of about an hour or so, the moon covers more and more of the sun, and eventually leads up to the very last point where the sun is just about to cover, or the moon is just about to cover the last of the sun. This is called the diamond ring effect. Now, if you look, it's called a diamond ring. If you look, first of all, on the left-hand side, you see the really bright spot.
Yes.
That's actually the last tiny vestibule of light peeking over the edge of the moon before it's fully covered. And if you look around the edge, you see the white glow. It looks like the ring, the band ring of a ring.
Yes.
So that's why it's called a diamond ring effect. But if you also look, you'll see just above and below the bright spot, you'll see kind of an orange color. That orange striped color along the edge, that's actually the photosphere, which is the outer edge of the sun showing through chromosphere. And then also on the opposite side of the opposite diamond ring, you saw the little prominences showing up because they're actually naked eye visible through a pair of binoculars or naked eye during totality.
Interesting. Yeah. So then next, Tim, I think you've put together a collage of images.
Yeah, so just a quick setup for this. When you take any one single image of totality, you'll get some amount of the solar corona. The challenge in shooting the solar corona is that near the sun it's very bright, but it's literally about 4 sun diameters distant from the sun are the outer reaches of it. And
on either side.
On either side. And those are very, very, very faint. So a photograph that nicely exposes the corona near the sun, you won't see any of that. And the photo that gets the outer reaches of the corona will completely the sun is just bloated. And so the trick that we use is to grab a bracketed sequence of images. In this sequence, you'll see it's actually 12 different exposures. Each exposure is twice as long as the exposure before it. It'll build up and then it'll fade out. You'll see us go through that progression. We then combine those using computer software to create a final result. So no one image is all impressive, but the final result of collecting the data gives you that effect.
Great. Let's take a look at that clip right now.
Okay.
Now, the final image that we have.
Yes, well, the final image, which is just after during totality, this is an amalgamation of all of the images shown in the video, actually processed and put together.
And we should point out,
Yes.
this image was taken by another photographer, club member Tony Licata. So
Correct.
this is not the data from the last video clip you just saw. This is a different
But this
one.
would be indicative if you
Yes,
did. This
if
is
you
what
did.
we would have.
Yeah.
We actually had a little bit of cloud cover, which is why we had extra bloat, and we didn't have a nice crisp moon in ours, because we had a little thin clouds that we were shooting through, and Tony did not. So he had much better, and frankly, he's more experienced.
Tony is very good. Yes, he is.
So so that's the end result that every imager hopes to get. Where you get a result where you can compile our images into something as final as that, and I think there's some images as well of actually the lead out, but it's pretty much here is the moon as it's just over halfway through its lead out, moving away from the sun, and as you see there, this is one of the last images I got because the little haze that's over the sun there. Because the one before is much clearer, is actually light clouds starting to move in.
Oh, I
and
see.
it got a little bit heavy. The clouds started to build up a little bit. So
Okay.
we didn't get the very last pieces of it because some cloud moved in, but we got some really good shots all the way through.
I would say they're fantastic images to be able to see the progression and learn how this was done and be able to pick up, as you say, that faint corona that would otherwise be invisible to us. Well, this part of the show has been really quite interesting, but we do have a second segment to the program where we're going to talk with some of our club members who viewed it visually, and so we want to have some time for that as well. We're going to take a quick break. As always, if you have a question, send us an email, please. You can see the email address down at the bottom of the screen, as always. And right after Term of the Month with Stephen, we'll be back with the visual aspect of Solar Eclipse 2017.
The term of the month for October 2017 is Diamond Ring. So this isn't anything, it doesn't have anything to do with Saturn or anything that you put on your finger. This is the last bit of light that you see just before totality, the total eclipse of the sun. So the moon is there making it all dark. And it's really awesome. But remember, it's a little bit of the sun, so it could possibly hurt your eyes. This is the last time you need eye protection before totality. Term of the month, October 2017, Diamond Ring.
Thanks, Stephen. Welcome back to the program. In this segment, we're going to talk to some of the visual observers, folks who really didn't take any pictures, which is fine. Not everyone needs to do that. And so we're going to get their experiences and feelings about this wonderful event. Going to start to my immediate left here with Kevin Bedden. Kevin, welcome back to the show again.
Thanks a lot, Don.
So, where did you go to view the eclipse?
I went to Sparta, Tennessee, a town of about 5,100 people. Quite worried about the climatological data because, again, clouds and mountains don't mix and they tend to pop up a lot, the clouds that is, in the afternoon. But, I prepared myself. As you can see, I had books, magazines, the whole 9 yards. And I bought myself a pair of solar binoculars to help myself out. And
Dedicated strictly to solar viewing.
right. In other words, the directions were kind of funny, you might think, but the first thing they told me was, if I could see anything out of these besides the sun, don't use them.
Good point.
Which sounds like a fair enough thing here. And
All right, so I understand you've got some images from down in Tennessee?
yes, this is your typical Walmart parking lot in Sparta during a solar eclipse. As you may or may not remember, Walmart allows you to camp out on their parking lots. So these fine folks took advantage of that opportunity, have all their equipment ready, and this was probably taken at least 2 to 3 hours before first contact.
Okay.
And this is a small park called Pearson Park in Sparta, Tennessee. 25 cars in this parking lot, but get this, 18 states are represented, 1 Canadian province, Ontario, and somebody even left the government in the lurch by leaving Washington, D.C.
Interesting.
And again, you can get an idea of the people here at Pearson Park as they gather, and again, this is at least, hour and a half, 2 hours before the show is even starting.
Okay.
Eventually, a crowd of kids even shows up on 3 busloads. Now this image probably looks really silly to a lot of people, but this is what you can get if you do it properly with your iPhone.
Okay, I assume you also had some proper filtering too.
Right. Not only was the person using the camera had her eyes filtered, the camera itself was filtered.
In the smartphone.
Right.
Interesting.
Because you didn't want to obviously burn out any of the camera parts on the phone.
This is true. This is true. So that's with some very basic equipment like a smartphone, you can get some interesting images.
Right. And since this was my first one, I elected not to worry about imaging.
Excellent choice. Excellent choice. Next is Tim Day. Tim, welcome back to the program again.
It's a
Glad
pleasure to
have
be
you.
back. Thank you, Don.
Now, where were you during the solar eclipse?
I stayed home, which for us here is Lincoln Park, and I run an observatory there with the help of the Ford Amateur Astronomy Club. And we were interested in reaching out to as many of the people locally as we could. So with the help of the local paper, the News Herald, we had some publicity, and we had a good turnout, a couple hundred people at the least, all sorts of family, everybody from mom and dad and grandma and grandpa to just the youngest kids, and we were able to hand out the safety glasses that we were gifted from NASA.
Great.
The club was given several hundred, and I was allocated a good share. And folks were lined up to get them, and we were happy to hand them out and help them to have a good time.
I understand you've got some images from this event.
We do. Let's take a look. This is the observatory, the Hector J. Robinson Observatory. It's on the Lincoln Park School grounds by the track, and we make it open to everybody free of charge on nice clear nights. It's good if it's warm. Folks tend to turn out. Weekends are popular. So here folks are, instead of being inside, they're looking up. And you can see the safety glasses, and people had lawn chairs and lemonade, and it was just a good old time. That's me inside the observatory looking down the barrel of the biggest telescope. We didn't actually use that because there wasn't occasion for it. What we were looking at was easily visible with just your glasses.
Just naked eye observing.
Just naked eye. And here's a bigger view of the observatory, and you can see that there are several telescopes, and we're gifted with all sorts of nice of equipment there. And again, folks are welcome to come out. There's no charge. Again, the outside of the observatory, you can see the high school in the background. There's a teacher there in a pink shirt. His name is Leo McMaster. He was instrumental in getting the grant. He and I worked together. And here's an astronomer, one of our club members from Ford Amateur Astronomy Club. His name is Gary Gibson, and he's demonstrating solar projection, a way to show a lot of people what's going on through a telescope, but they don't have to put their eye up to it.
Similar to what Liam was doing with the...
Very
eclipse
much
on the
so.
first segment.
Yep, and there's a better shot of what people were looking at. That's pretty close to the 80% that we got here in Lincoln Park.
Yes, as I recall, I remember viewing it from where I was as well for just a little bit of time.
Yeah.
So it sounds like it was a very successful outreach event for the observatory.
Anytime we get to raise awareness with the public to educate, that's a good time. That's a good opportunity. And we feel that we got a lot of excitement, and we're able to perhaps plant some seeds for the future astronomers.
Great. Thank you for sharing that with us, Tim.
My pleasure.
Now we come to Ken Anderson. Ken, where were you?
So I was out in Casper, Wyoming with my wife and Liam and Tim Campbell. And in the first picture, my dark apparel hood on, it's a solar hood, so it's white. This enables me to see the sun better, and if you look at me in the camera, you'll see the binoculars right behind me that I was
Okay, that's
using.
the set right there
So
that
you
you
can
were
see the
looking through?
binoculars right behind me. So they do have solar filters on it. So for the first part of the eclipse and the last part of the eclipse, when it's a partial eclipse, I was able to use these binoculars. And if you just flip over to Don Glaser, you'll see the solar Max 40 hydrogen alpha telescope that I was able to see the prominences in. So now we can go look at the pictures that we had. So this is actually taken the day before the eclipse, but it's a nice clear shot with sunspots on it.
Yeah, very prominent, as a matter of fact.
Yes, and if you go to the next sunspot, so this is the beginning of the eclipse, and in here you can see 4 sunspots in a row, and then 2 sunspots right on the limb opposite of the bite of the eclipse. So the eclipse progresses from left to right, blocking out those sunspots and finally blocking out those 2. And then go to the next slide. And then, so here's me looking at the Hydrogen Alpha telescope. So in Hydrogen Alpha, I would see the sunspots. I would see like a bright faculty surrounding those 4 sunspots. I would see a prominence over at 3 o'clock. It was a really large prominence, probably like twice the size of the Earth. You can go to the next picture. Go to the next slide. Okay, so this is what it looked like in totality. So all of a sudden the sky got a lot darker. Go to the next slide. And so this is Tony Licata's post-processed image of the corona, which is actually hot plasma, 10,000 degrees. And this is about the closest image I could find to it. So you see those white hair-like structures. So part of it looks like it's coming out of the pole, and part of it was like looking like it was coming out like a beard at the other end. And these white-gray filaments, they appeared like fiber optics. They were really bright, glowing image.
Was
It's really impressive.
what we see in this image right here, Ken?
That's closest to what I saw with my eye. The one exception was if you go to the next slide. Go to the next slide. You didn't see the moon. It was very dark. This is also another view of what the total eclipse actually looked like. So you see all these filaments in here. So it's a really good picture. And now you can go back to the regular pictures that we have, and I'll talk about those. Okay, so this is Bailey's beads. So at the totality, you have Bailey's beads approach, and then the final thing is the diamond ring, which is the next slide. And the diamond ring is the signal to stop looking. Now, if you go back to the camera on me, when I'm looking at totality, I was using the 15 by 63 unfiltered binos. You know, these give a field of view of 3.5, and I had it on the pistol grip monopod. My wife was using these this Vixen Ascot 10 by 50s, and then had an 8.5 degree. And because I was a little concerned about her not looking away at diamond ring, I gave her the lower power, smaller aperture binos. And actually, when I stopped looking, I told her to stop looking, and I looked over, and she was still looking. And she goes, "Wow, this diamond ring is really good." I go, "I told you to stop looking." So that's why you got to be really careful when you're looking at unfiltered, which is safe to do during totality, but not when you start going through the partial eclipse again.
Exactly. Well, you know, I think this has been a really fantastic program. I've looked forward to it for several months when we were talking about it, and glad to get the observers and the imagers back so that they can share their pictures and their experiences with you, our audience. I want to thank you all of my guests, for being here on the program. Please visit our website, the club website. The address is down at the bottom of your screen. We always like to have you check that out for information. And coming up next is What's Up in Our Night Sky with Stephen. So thanks for watching.
What's up in the night sky for October 2017? The sun rises from 7:30 to 8:05 over the course of the month and sets from 7:14 to 6:27. So the days are getting shorter as we head toward the winter solstice. Twilight this month is, at least here in Michigan, it's an hour and a half. It ends an hour and a half before sunrise, and it begins again an hour and a half after sunset. So that's pretty easy to remember all month long. The full moon is on October 5th. The third quarter is on October 12th. The new moon, you won't see it, is October 19th. There really isn't a picture there. And the first quarter is on October 27th. Now, Mercury is best on October 31st, and we see it here at 6:30 p.m., so 6:30 in the evening. So Mercury way in the right-hand corner of the picture, of the image, of this, really the sky chart. So at 6:30 p.m., so this is just after sunset, Mercury is at its best elongation from farthest from the sun at 14.2 degrees from the sun, and it sets at 6:54 on the 31st. Mercury goes from Virgo to Libra over the course of the month. It has a solar conjunction on the 8th of October, which means that it goes from rising to setting, right? And since the end of the month is farther from October 8th, that's when it's better. Aphelion is October 29th. That's just when Mercury is closest to the sun. Saturn here also is in Ophiuchus. It has a conjunction, superior conjunction coming up on the solstice on the 21st of December. So Saturn is is getting closer to sunset every night. It sets currently almost 11 p.m. to 9 p.m. over the course of the month, so it's better at the start of the month. Neptune is in Aquarius. It's up most of the night. It currently sets from 5 in the morning to 3 in the morning. And then Pluto is in Sagittarius, setting from just after midnight to about 10:30. Now, also at the end of the month, but at 6:30 in the morning, Mars and Venus. Venus goes from Leo to Virgo, and Mars goes from Leo to Virgo, because they're really close to each other. Venus is best at the beginning of the month, even though this is a shot at the end of the month, and Mars is best also, is actually best here at the end of the month. So they rise, 5:30 in the morning. Jupiter is in Virgo. It has a superior conjunction October 26th, so this is an awful, awful, awful month for Jupiter. And then Uranus is in Pisces, and it's at opposition, so it's great for naked eye seeing if you've got a good sky chart and maybe a telescope to find it. And that's what's up in the night sky for October 2017. We don't charge for Astronomy for Everyone, but we may tax your brain.